Okay, here's warm-up 9.8.1. I'm going to write this in simple radical form. So got a radical in the denominator, so I need to rationalize the denominator. A lot of times I'll see people try to multiply by root 5 over root 5, but you'd have to distribute the square root in the bottom, and you'd still end up with the square root in the denominator. So what I want to do instead is multiply by the conjugate of the denominator. The conjugate would be 2 plus root 5. You change the sign of the radical. And then I'd have to do the same thing to the top. So on top, I'm going to distribute the 3. Let's see, I'd get 6 plus 3 root 5. On bottom, I'm going to FOIL. So first is 2 times 2, 4. Outer is 2 times root 5. Inner is going to be negative 2 root 5. And last is going to be negative root 5 times positive root 5. Well, negative times a positive is negative. And then if I combine parts under the radicals, I've got root 25. Okay. All right. The outer and inner are opposites, so they drop out, so that's really nice. And then the square root of 25 is 5. So I'm going to have 6 plus 3 root 5 over 4 minus 5. So, hey, that's 6 plus 3 root 5 over negative 1. And when you're dividing by negative 1, you can just change the sign of both terms. And this is simplified, and it's in simple radical form. Okay. All right. The rest of these, I've got some trig expressions that I'm going to simplify using some identities. Okay. So in general, a good strategy, I think, is to write everything in terms of sine and cosine. So I'm going to take all 4 of these bits and write them in terms of sine and cosine. That first piece is already in terms of sine. Tangent, though, is not in sine and cosine, but I could write it as sine of theta over cosine of theta. It's one of the identities, the trig identities. That's what tangent equals. And the cotangent, since it's a reciprocal of tangent, then I've got cosine over sine. Okay? Cosecant is going to be the reciprocal of sine, so that would be 1 over sine of theta. Okay? So now I've written everything in terms of sine and cosine. It still looks like a big mess, but this is actually going to simplify really nicely. So I could combine this all into one big fraction, or you could kind of just start doing some reducing right now. So remember this first sine of theta, that would, if you combined it all, that would be in the numerator. Okay? So let's look at this. I've got a sine here and a sine there, so those are going to reduce. I've got a cosine here and a cosine there, those reduce. And then this sine and that sine reduce, and then there's nothing much left except for a 1 in the numerator and denominator. So this simplifies to exactly 1. Okay? Kind of makes sense because these are reciprocals, so those multiply to 1, and the 2 on the inside are reciprocals. They multiply to 1 as well. Okay. All right, next up, I've got in this one I've got some squared terms. So the first thing I would think is, well, maybe I can do something with one of the Pythagorean identities. So I'd want to use the one that uses sine and cosine. And that says that cosine squared theta plus sine squared theta is going to be equal to 1. Okay. So I can play around with this a little bit. So I could solve this for cosine squared so that I can swap that denominator out with something. So let's see. Actually, I don't want to do that, though, because if I isolated cosine squared, I could subtract sine squared, but then I'd have 1 minus sine squared. Actually, that will work out nicely. Lots of times there are different ways to do this, and this just occurred to me. But, yeah, if I'm taking this here and solving it for cosine, it's going to equal that, right? And I was about to say that I'm creating another term, so it's getting less simple, but it doesn't matter because now the numerator and denominator are equivalent, so this is all going to equal 1. I could have also taken the top here, and that would be equivalent to cosine, so maybe that would be a simpler way to do that. I could have replaced this with cosine squared, but either way, it reduces to 1. Okay? All right, next up, this is a little more complicated here. So I'm going to start by writing everything in sine and cosine. So I'll leave this cosine alone. Secant is the reciprocal of cosine, so this would be 1 over cosine. Okay, and then secant, again, is the reciprocal of cosine, so this would be 1 over cosine down there in the denominator. Okay, so looking at this piece, I've got a cosine in the numerator and 1 in the denominator, so this is going to reduce to just 1. A lot of times I'll see people just cross this out and lose this all together and just say this is all we have left. Well, it still reduces to 1, right? I have a 1 in the numerator and the denominator. Okay, I'm going to write this complex fraction as division. So I've got cosine theta divided by 1 over cosine theta. And now that I've got it written as division, I could rewrite it as multiplication. Okay, and then, hey, that's going to be cosine squared. Okay, and you could play around with the Pythagorean identities again. So if cosine, here's my Pythagorean identity. So I'm looking at that and thinking, okay, can I get one of the sides to say 1 minus cosine squared? Sure I could, by subtracting cosine squared theta from both sides. Okay, and now this is going to be equivalent to 1 minus cosine squared theta. So that's considered a little bit simpler because it's just one term instead of two. And that's as far as we can go with that one. Whoops, I got off screen there a little bit. Sorry, there's my final answer, sine squared. Okay, theta. That's it for this warm-up. See you next time.